Okay, we're ready to begin section 2.6. 2.6 and 2.7 are functions. And remember why I said we were skipping around. I just looked through the beginning of the book and picked all the sections that I thought were important, prerequisite information that you should know coming into the class. So whether you know it or not, I'm giving you a chance to learn it to help you be successful in the rest of the course. So first we had the lines and the slope and solving equations. Now we have functions, so 2 sections in a row. Functions are something, actually everything we've done so far, you're going to see in every math class you take. So there's a reason why I picked different sections, but you will see this over and over again. So what is a function? So we say that y is a function of x if each element in the domain is paired with exactly one element in the range. And remember, the domain is the x, the range are the y values. So each x value is paired with exactly one y value. Let's put that in our terms. So each x value is paired with exactly one y value. So now we have it in layman's terms. So each x value is paired with exactly one y value. So what that means is, let me show you one that's not. This x value, because x is always on the left, y is on the right. It's always alphabetical order. This x, 6, is paired with 4. And then here it is paired with 3. Can't happen. That x value is paired with 2 different y values, so that would not be a function. Where here, 4 is only paired with 1, 6 is only paired with 1, 8 only goes with one value, 10 only goes with one value, so that one would be a yes, because each x only has one line going from it. This means no order pairs have the same first coordinate in different seconds. So if you look here, this would be 6, 4, and then it would be 6, 3. So 6 goes with 4, and then 6 goes with 3. And see, it says each x cannot have the same first coordinate and different second. So if you see the x repeated and it has different y values, you immediately write no. So determine whether it's a function, state the domain and range. So as I said, the domain, and maybe this is a highlighter moment, the domain is the x values, and the range are the y values. So because they're a set, we do have to use set notation. So our domain would be 4, 6, 8, and 10. And it's the set of x values. That's why we need to use the set symbol. So 4, 6, 8, and 10. Our y values would be 1, 4, 5, 3. And there's no need to put them in order. I just keep them in the order of the problem. Another thing you don't do is repeat. So if there had been 2 4s over here, I wouldn't write it twice. I only write each element once. So here it's not a function because 6, and you could use color and show why, 6 has 2 arrows going from it. That means 6 is paired with 2 y values, and this says only one y value is allowed. So my domain's the same, 4, 6, 8, 10. And my range is the same, 1, 4, 5, 3. But it's not a function because the x value 6 is paired with two different y values, which you can see right here. Could draw this and show why. Okay, so look at C. So before I tell you the answer, tell me what you think. Function or not? Say no, say no. 5 goes with 5. Oh, and then look down here. 5 goes with 7. The easiest way to tell is look and see if your x is repeated. If there's an x repeated, see if it's paired with two different y values. And if it's paired with two different y values, then it's not a function, just as this note means. So this means no ordered pairs can have the same first coordinate and different second coordinates. Same first, but two different y's. So this is not a function, so be sure and point those out, why it's not. And if you had to write a sentence about it, which we make students do in 091, we'd say, this is not a function because the x value 5 is paired with two different y values. Okay, to name the domain and range. The domain, remember we don't repeat, so don't write the 5 twice. So it'd be 5, 2, and -2. And the range would be 5, 8, 7, 6. So the range are the y's, the domain are the x's. And we never repeat elements in the domain or range. That's why we didn't write the 5 twice. Okay, so look for a repeated x. If you see one, look and see if it's paired with two different values. If this had been 5, 5 again, then it would have been a function. But because it's paired with a 5 here and a 7 here, that makes it not a function because of this right here. So it can't have two different y values. And also because of here, each x is paired with exactly one y value. Okay, so we know how to tell a function when we're given a set of ordered pairs. How do we tell if it's a function when we're given a graph? And that brings us to the vertical line test. Vertical line test, pretty big. So the graph is a function if no vertical line intersects the graph in more than one point. So we pass a vertical line across the graph, and if it only intersects once, it's a function. If there's any place where I could intersect it twice, it's not. So for instance here, if I pass a vertical line here, we hit it once, because we're looking at the function, not the axis. So pass this vertical line here, and you could see I only intersect it once. So, and any other vertical line, same thing. So that means it is a function because the vertical line only intersects it in one point. So that's a yes. So let's do our yes and no. And then we'll do the domain and range. So here I have a vertical line. Oh, wow, look at that. That vertical line intersects the graph twice. So that would not be a function because it says any vertical line. So we can't just say, well, this one only intersects it once. Well, this one doesn't, so that makes it a no. And this one, once. So this one would be a function because a vertical line never intersects it more than once. So this would be a yes. Okay, domain and range are a little bit tough for students on graphs. First off, I want to, and you should do the same thing if you have a colored pen or pencil, let's trace the function in a color. And I want you to realize that when it's a computer graph, they don't put the arrows on it, so we're going to put the arrows on. So that graph looks like that. I didn't draw very well, sorry. This graph has arrows, 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 arrows. This one you can see ends at a certain spot, so there's no arrow there, but that one would have an arrow. Okay, so domain are the X values, and range are the Y's. So I always tell students when you're doing domain on a graph, go left to right. So what's the leftmost X value? Notice there's no X's here. No X's here. Here's where my first X is, and you can see this slides right along the Y-axis. It doesn't cross it, so that means that X will never hit 0. So we put a parenthesis to show it goes up to 0, but it never crosses 0. And then going right, we see it goes forever, so we write infinity. If you were using an inequality, you'd say X is greater than 0. Because I know Alex has you use both. Most teachers only want this. This is called interval notation. And this is called an inequality. So depending on what Alex wants, but like I said, all your classes after this are going to want interval notation. So no X's, no X's. The X's start as 0, but they never hit 0 because they crawl right along the Y-axis. So they start as 0. That's why we have a parenthesis. And they go to infinity. And we learned in our inequality section, infinities never get a bracket. They always have parentheses. Okay, this domain is much more difficult. So going left, see the arrows? That means it goes all the way to negative infinity. So it'd be negative infinity, comma, oh, we forgot to do the y's. I'll come back and do those. And then it goes up to, is that negative 2 it looks like? Yep, and it's an actual point. So because it's an actual point, we put a bracket. Here it never hits 0, it just crawls along the axis. But here, negative, oops, that's negative 3, isn't it? It is an actual point on the graph at negative 3, 0. And then there's a gap, so we write a U. And then it picks up at positive 3, where it's an actual point again. And it goes to positive infinity. So this one has 2 intervals. This interval, which we always have to name them left to right, negative infinity up to and including negative 3, hence the bracket, united with, just as like saying and, 3, another bracket because it's an actual point on the graph, all the way going right to infinity. And order matters, just like on our inequalities. You have to have left to right, left to right. So order matters, the shape of the brackets and parentheses matter. So this range I can see goes down forever. Range is bottom to top. And this range goes down forever and up forever. So that range is going to be negative infinity to positive infinity. So it's going to go down forever and it's going to go up forever. Same thing with this one, right? Down forever, up forever. So that'd be negative infinity to infinity. And I guess we'll do the last domain and range in the next video because we're out of time.